Welcome to qnawire.
For the x-intercepts of this graph, let's solve the equation 0 for y equals x squared minus 2x minus 35, which can be in factored form. We'll multiply as a negative 35 and adds to negative 2. That would be a negative 7 and a positive 5. That's in factored form, which means the x-intercepts are at positive 7 and negative 5. The vertex can be found in a variety of ways. One way would be to complete the square. And so if we have 35 equals x squared minus 2x, we can complete the square with the x's and say let's add half of negative 2 is negative 1 squared is 1 to both sides. And then we get 36 equals a perfect square trinomial x minus 1 squared. And then subtract 36 to both sides, and you have x minus 1 squared minus 36, which means the vertex is at 1, negative 36. The x-coordinate should also be in between the two x-intercepts. Notice there's 6 units between both. Number 2, solve the following inequality. Well, based on the information, we have critical points at 2, because that'll create a 0, at negative 1, and at, because this is the same thing as x minus 4 times x plus 4, 4 and negative 4. So let me put these in order for us. If we were to have a number line, and we had the solutions negative 4, negative 1, 2, and 4, we want to test what's happening. And we would want to know, when is this greater than or equal to 0? We know it's equal to 0 at all of these critical points. But when is it greater? We have to test. So like we would test, for instance, negative 5. Then we would have 2 minus negative 5 is 2 plus 5 or 7 times negative 4 times 25 minus 16 is 9. And we get a negative answer, so we're not greater than or equal to 0 left of negative 4. Let's test something like negative 2, which is in between negative 4 and negative 1. 2 minus negative 2 is 4 times negative 1 times 4 minus 16 would be negative 12. We get a positive 48. So we are greater than 0 between negative 4 and negative 1. Then we test something like 0. That would be 2 times 1 times negative 16. That would be a negative value. So we're not positive in between negative 1 and 2. And then we have one more region, two more regions to test, between 2 and 4, so I'm going to pick 3. 2 minus 3 is negative 1, times 2 plus 1 is 3, times 4 squared minus 16 is a negative 12. We are positive here. and then greater than 4, like 5, we'd have a negative 3 times 6 times 25 minus 9, or 25 minus 16, which is 9, and we can have a negative 162, not greater than or equal to 0. So how does this help us? This would mean the solution would be, we would be greater than or equal to 0 from negative 4 included to negative 1 included, union from 2 included to 4 included. If we had x squared plus 6x is less than negative 8, let's add 8 to both sides so that we're less than 0. And then we can factor. We'll multiply to the 8 and adds to 6, 4, and 2. So negative 4 and negative 2 are important regions for this quadratic. We need to know what's happening here. Well, if x is something less than negative 4, like negative 5, we'd have negative 1 times negative 3, which would end up being a positive. So it's not, it's not less than 0. Something in between negative 4 and negative 2, like negative 3, we'd have 1 times a negative 1, which is negative, so that would be true. Then something larger than negative 2, like, well, I'll just pick 0. In the unfactored one, that would mean 8 is less than 0. That is not true. So it's between negative 4 and negative 2. Not included because it's not or equal to. And I think that's good based on, well, I can see this last one. I think it looks like it's 9x squared plus 5x minus 1. So with the quadratic formula, which is opposite b plus or minus the square root of b squared minus 4ac all over 2a, where a is 9, b is 5, c is negative 1. So x would be equal to negative 5 plus or minus the square root of b squared, which would be 25, minus 4 times ac, which would be negative 9, all over 2a. So negative 5 plus or minus the square root of 25 minus negative 36 is 25 plus 36, which is 61, over 18.